Hi, in this video we're going to talk about moment of inertia. Moment of inertia has a symbol with I. And what is moment of inertia? In a very most simple way, it's basically a measurement to measure the resistance of rotation, right? Resistance of rotation. And again, when you rotate something, it's about particular axis. So it's resistance of rotation about a specific axis. So for example, if thinking about it, if you have a book in your hand, you want to just rotate at the in the center of the book. That's relatively easy, right? And then imagine you are here and you extend your arm out, and here is, imagine you have a very super stretchy arm, and here's a book. You are rotating. Now you are rotating at the center of your spine, your body. In that situation, you realize it's harder, right? Then you realize the resistance I1 and compared to I2, even it's the same object, the same textbook, you are rotating, but when they are rotating about different axes, the resistance is different. Here I2 has greater resistance than I1. So moment of inertia is different. Okay? Then when we're talking about resistance, now we're going to look at a formula for Ix. If you want to try to find something rotating about x-axis, for example, I have a rectangle shape. My x-axis happen to be at the base, and my y-axis is happen to be the left edge. And we know since now we're rotating differently. If I rotating this this textbook rotating about x, so it's gonna rotate in this way. And if I'm rotating around here, it's gonna rotating in a different way, IY. So Ix is gonna be different from IY, and Ix, here's a formula for any shape. You can use the same formula. It's gonna be integration of y squared and dA. But then, how do we draw this dA? Here's very important. If you're finding moment of inertia regarding x-axis, you're going to draw your rectangle horizontal. Okay? Then if you want to try to find IY, here's a formula. It's going to be x squared dA. In order to do that, trying to find a moment regarding y-axis, then when you draw that, you're going to draw, that's the rectangular strip going to be parallel to y-axis. It's going to be vertical rectangle. So those are the most basic rules to solve your moment of inertia. Now, again, I'm gonna just give you a heads up. This is actually the how would you say, this is that works, but sometimes the problem can be simplified. You have to be flexible. Just keep in mind now, this is something you can always go back to find the moment of inertia. So knowing that, let's go ahead and trying to solve. How about if I have a rectangle, have a base B and a height H, and I'm going to rotating about x-axis, and also I'm going to rotate about y-axis. So I'm going to find the Ix and the Iy respectively. How do we do that? So solve Ix. Remember, you're solving Ix. The way we are going to do is we're going to draw a rectangle that is parallel to Ix. And then, because we did that, and our Ix formula will work as y squared dA. Now let's take a look. This is B, this is H. And let's look at this rectangle here. What's going to be our rectangle? If I'm extract that out, my base, what's the length here? It's going to be B, right? And what's the height here? That's going to be our differential length. That's going to be our dy, because here is x and a y. That's going to be, so in that situation, we will know our dA, this area, is going to be b times dy. So knowing that, plug into our formula. Ix is equal to integration y squared dA. For that situation is b dy. Plug it in, take the b out because b is a base, that's a constant. So we have b y squared dA. Then when you integrate the y squared, then we will have 3y cubed b. And y, the range is going to from 0 to h. Right, this is a y range from 0 to h. Then we can solve that. That's going to be b h cubed. Does this look familiar? Ix, we have a rectangle rotating about the bottom base. It's going to be 1/3 bh cubed. You probably already learned this in freshman engineering class for moment of inertia. You know the formula, right? Now we know how we get there. Now let's go ahead trying to solve Iy. So in order to solve Iy for this rectangle, same base and height, and we're going to draw the rectangle that is parallel to y, so which is vertical, and our formula will be correspondingly x squared dA. Now let's thinking about this rectangle strip, and what's gonna be the length here? That's gonna be our dx, and the height here is gonna be take up the h here. So in that situation, our dA for that rectangular strip will be h times dx. So plug it into this equation here. Y will be x squared times dA h dx. Taking h out, we'll have x squared dx. And integrate, we'll have 1/3 h x cubed. And what's x range? X range is from 0 to this length b. From 0 to b. Then what would we get? Would be 1/3 h b cubed. That's going to be our Iy. Okay, so I want to take a moment to compare Ix and Iy. For this rectangle, if I'm rotating about x direction, I have h being cubed, right? And you realize if I'm rotating about x direction, is going to be how much area is distributed away. So here I want you to pay attention, see the pattern here. Area distributed away from your rotational axis. So area distributed away, so basically what is a major factor? H, because that's how far away from this axis. So that situation is going to be h cubed. In other words, if there's more, if this area distributed away from rotational axis increases, what do we get? Our I, moment of inertia, will increases. So that is a very important pattern. If there are more area distributed away from rotational axis, then we're going to get more moment of inertia, more resistance to rotation. Make sense? All right. So now let's look at Iy. If you are rotating about Iy, so y is our rotational axis. How much area distributed away from it is going to be this side. So the dimension will be b. So b is being cubed. Okay, so b matters now. All right. So just look at this shape. One more thing I want to talking about for this shape, obviously my height is greater than b the way I'm drawing. So you will know if I will position this shape, if I distribute it away, if it's rotating about Ix for this situation, is going to be greater than Iy because Ix is h cubed. H is greater than b, and my Iy here is going to be b cubed. Okay. All right, so that's for our rectangle. Those are the common formula: 1/3 bh cubed and 1/3 hb cubed. Yes, I would expect you to remember that as engineering students. So now let's take a look at this table here. And this table is taken out from your textbook. It's inside of your back cover or front cover. Uh, then here they give us some other common shape. For example, this rectangle, it's going to be, they give us this ix, 1/3 bh cube, which you just calculated. Y, it's regarding this axis, left edge, it's 1/3 h b cube, right? And then they also have some other ones. Pay attention. They have this x prime. This x prime is no longer the bottom edge. X prime going through the C centroid. So basically, if it's rotating about this x prime, you realize it's 1/12 bh cube. Okay? And if you're rotating about the centroid y-axis, it's going to be 1/12 b cube h. We can quickly make a prove that. So here's the example 2. So we're going to have the same rectangle. However, this time we're going to have this x-axis is going through the centroid, and we have this y-axis going through centroid. And we're trying to find this ix prime and y prime. What would that be, right? So if you are going to look at ix prime, we're going to go back to using the same formula. We're going to draw our rectangular strip that is parallel to x prime, which is horizontal. Now we're going to use a formula, which is y squared dA. Okay. Now let's look at this strip. Entire length here is going to be b, and the height here is going to be our dy prime, right? dy. Let's just say called y. So in that situation, I will have y squared, and the dA will be my base b times dy. And taking out the b out, I will have y squared dy. Integrate will be 3y cubed over 3. And my y, what's my y range now? This is different. My y range is going to from this value to that value. Entire length is h, so this value is going to be negative h over 2, and this value is h over 2. So negative h over 2 and h over 2. Let's plug it in. We'll have 1/3. So h over 2 cube minus negative h over 2 cube. Right? So let's go ahead and solve that. So that will be b cubed, and this is going to be minus negative, so it'd be plus. Then what do we have? We'll have 2 over 8, which is a quarter. So that will give us, answer is 3 times 4 will be 12. Oh, this is h, my bad. So that would be 12 bh cubed over 12, right? And that's exactly what you have in the table right here. How do they come up with that value? Agree? So hopefully you can go ahead and do the same thing. You can go ahead and solve iy prime. You will figure out the same thing. In that situation, I will go ahead and draw this. If this is your rectangle, this is the x prime and the y prime. And for iy prime, you're going to draw that's vertical, right? So for that situation, you will use in formula x squared dy and our dA, sorry. And the dA, and so we're going to figure out this rectangular shape area. This is going to be our dx. And if this is b, this is h, so this length will be h. So the area will be h times dx. So taking h out, integrate x squared will be get x cubed over 3. And now let's look at the range for x for this situation. My left edge is x, it's going to be negative b over 2. And the right side, my upper limit will be b over 2. So b over 2 versus negative b over 2. So same way, just like how you calculated earlier, you can have b over 2 cube minus negative b over 2 cube. All right, so that would be 8b cube plus b cube over 8. Then that will give us the answer as 112 hb cube. Okay, so you look at the difference between those two. The same principle applies. If it's regarding area distributed away, if it's away from x prime, then the primary dominant dimension will be my h dimension, so h is being cubed. And however, if I'm rotating about y-axis, area distributed away from it, it's going to be in this dimension b, so b is being cubed. All right, so that's our moment of inertia, how we get it. By the way, I'm going to talk about one last topic, is what is the unit for the moment of inertia. The answer is meter to the power of fourth, or the length times power of fourth, or foot power of fourth, because we know it's length square and times area. Or from this rectangle, you know it's, let's see, 1/3 h meter times meter cube. So the answer is meter to the power of fourth. All right, so that's for moment of inertia. I'll see you next time. Bye.